In this presentation, we are going to look at discrete random variables and the joint distribution of discrete random variables. So in this case, what we have is a pair of dice. A pair of dice is thrown, and let x denote the minimum of the two numbers which occur. Find the distribution and the expected value of m, which is the pairwise minimum. So what I'm going to do is set up all the possible outcomes of dice 1 and dice 2. So just assume that dice 1 and dice 2 both give 1 to 6. So 1, 2, 3, 4, 5, 6. So that's dice 1. And dice 2, 1, 2, 3, 4, 5, 6. So what we have here is the possible outcomes, the possible pairings of dice 1 and dice 2. So for example, in the top corner we have a 1 from dice 1 and a 1 from dice 2. So 1, 1. Okay. Now in this case, what would be the pairwise minimum? Well, the pairwise minimum would be 1. Okay, so 1, 1, what's the minimum of that? 1. Likewise, for each of these possible outcomes where dice 1 is involved and it gives 1, the minimum value is going to be 1. Okay. If we throw 1 from dice 2, that's always going to give us a value of m as 1 as well. So you sort of see how this is working out. In all of the cases that I have highlighted, the minimum value of the pairing is 1. Okay. Let's look at what happens when we roll 2. Okay, with dice 1. Now just disregard the case where we get dice 1 from dice 2. Okay, so apart from what I have highlighted, so apart from that first cell, if dice 2 gives us 2 and above, and dice 1 gives us 2, that means the pairwise minimum is 2. And vice versa. Okay? So you can sort of see what's happening here. That we are picking out the rows and columns that give us a minimum of 1, a minimum of 2, a minimum of 3, and so on. This will give us a minimum of 4 here. These cells. Okay? Pairwise minimum, and so on. So that's what we have here. So that corresponds to those pairwise minima even, if you will. Okay? So here in these cells that correspond to those two possible outcomes from each of the respective dice, the minimum is 2, and in the cells I'm about to highlight, the pairwise minimum is 3. Okay? And so on. Okay. So the last case will be what happens if we throw 6 and a 6. In that case, the pairwise minimum is 6. So hopefully you can sort of tell the pattern there now. Okay. So let's count out the number of cells that correspond to each of these values of m. Okay. Well, in this case, where m is equal to 1, that's 11 cells. Okay. Where m is equal to 2, that's 9 cells, and so on. So there'll be 7 for where m is equal to 3, 5 where m is equal to 4, 3 where m is equal to 5, and 1 where m is equal to 6. Okay, so that helps us create the distribution of the values of m. Okay, so here is the possible values of the minimum. 1, 2, 3, 4, 5, 6, and this is the corresponding probabilities. Now, just as a sort of quick remark, we are assuming that each of the possible values of both dice are equally possible. So that's 2 fair dice in each of these, in all of these cases. Okay, so that is the corresponding probability for each value of m. 11 over 36, 9 over 36, 7 over 36, 5 over 36, 3 over 36, and 1 over 36. Something you should do is just check that does that add up to 36. Yes, it does. 11 plus 9 is 20, plus 7 is 27, plus 5 is 32, plus 3 is 35, plus 1 is 36. So 36 out of 36. Okay, so what's the expected value of m? Well, what we're going to do is take the conventional approach. For each possible value of m, we're going to multiply that by the probability and sum them all up. Okay, so 1 times 11 over 36 plus 2 times 9 over 36 plus 3 times 7 over 36 plus 4 times 5 over 36, plus 5 times 3 over 36, plus 6 times 1 over 36. So essentially what we could do is just sort of reduce them down a little bit, okay? And what you should end up with is 91 over 36, which is 2.527. Okay, so that's it.